Okay, how's everyone doing? Living the dream. Awesome. Okay, any questions about where we're at or where we should be at? Do you know where you're at? That's good. I did a little video this morning. I think 5 people have already watched it and just kind of went over the timing. Although after I did that, I realized, I believe campuses closed on President's Day, February 19th. I think I've got a schedule to be here, but so I'll make 100% sure and then I'll do an update. So I think that's Monday, the February 19th. So I'll check, but I'm pretty certain we're closed. So we'll make the adjustments we need to. I think that's the day, that's after our next test anyway. Okay, so today we start into lesson 3, which is average rate of change and linear equations or linear functions. So hopefully, if you've had Math 90, 91, 92 recently, this should be very much review for you because that's exactly what we're going to do. I'll show a few techniques. If you weren't in my class, I have a few techniques that help with finding slope and some of the other things that might cause you problems if you mix numbers around a little bit. So that's what you'll get from today. Also, I realized I started watching the video for Wednesday's class, and I think it was this one. I forgot to switch to the screen. So while I'm doing working everything out, all you see is my face, which doesn't, I guess you hear me talk through it, but at least I got screenshots, so I've got those saved. But to save ourselves right now, I'm going to switch over the software to the screen now. Let's see. Here we go. So now the live stream's capturing the board. And what we'll do is we'll pull up the workbook. We'll work through a few of those examples, maybe some of the you-tries, because a lot of the media lessons, they're all contained in there. But again, I'm happy to cover anything that you have any difficulties with at all. So let's do that. Let's open up Math.AS over here. And just before class, I saw I had an email from one of our fellow students, and she was asking about the grade book had both homework and quiz scores in it, but I guess I had said you could do one or the other, and that's still true. So I'll get to work on updating gradebook probably this week, but I really just want you focusing on learning the contents. So we've had lesson 1, 2, and 3. Again, the quiz will verify that you understand the material. The homework is good practice, but a combination of those two will be good. As long as you're understanding, you'll be just fine. And but I'll start looking through the things and updating, but I find this is why I don't do due dates either. It's a little bit easier to just kind of let you keep focusing on learning. Okay, so we're going to use the worksheet pages from the book as sort of an outline to make sure I catch everything. And our main topics today will be average rate of change, which is slope. So we'll do a discussion of that first. Then we'll do a little bit of a review of linear functions, so that's y equals mx plus b. And we might get a little bit into modeling, and but definitely for Wednesday I'm going to save 3.5 and 3.6, which is using the graphing calculator to do linear regression, because that's going to be something we do in each of the sections afterwards, some kind of a regression. So that's something you really want to get down. And so we'll do 3.5 and 3.6 Wednesday, and we'll see how far we get today. My goal is to maybe get through 3.3 and get a fairly good understanding of things, and then keep on moving. Okay. So the other thing I like about, let's see, no, here it is. There we go, but I want the background to be black. There we go. Okay, there we go. So we're going to start off with talking about average rate of change. What is average rate of change? Oh, before we do that, I better have one more thing to plug in. Listen. What does average mean?
Always.
What's that?
Always.
Always?
Standard.
Okay, maybe the standard. What's likely to happen? Okay, along those terms, that's definitely. How about when we apply it to numbers? What do we usually mean when we say average with numbers?
It's everything combined and then divided by the number that you have.
Very good. So that's a statistical function. You add everything together, divide by however many you have. You have 10 items, you divide by 10. And that gives us a mathematical average. And that's kind of close to what we're doing, but we're getting not just an average of numbers, but an average rate. Okay? And when we talk about rates, what is required for a rate? What are some things? Can someone give me some examples of rates?
Units, dollars, cents.
Okay, good. It involves units. You came to school today somehow. A bike, a car, a bus.
Oh, is it
Miles per hour.
Go ahead. I think miles per hour. So there's the units. So it's not just units, but units that are a ratio. Okay, so rates involve things like, miles per hour, which are literally something divided by something else, right? The miles divided by however many hours. You go shopping, dollars per ounce, dollars per pound. So those are rates. So all sorts of rates, but rates are fractions, okay, unit fractions. And that's kind of what we're going to look at today. So let me see, the one thing I couldn't really find, let's see if I can draw a straight line. So I'm going to draw a y-axis here. It's not very straight, but we'll say that's the y-axis. And let's put our x-axis about here. Now that's better horizontally. So there's our x-axis. So if I have a point here, what are the coordinates of the point that I just put there? 2, 2. So over 2 and up 2. So we listed as 2, 2. Of course, that was probably a poor choice because now we don't know which x and y are the same, but let's try to do something a little different. What if I go to this point here, and what is its coordinates? 11. Did you count that? Okay. So we came over to 11. And then we go up 1, 2, 3, 4. Good. Now these points are in a function. That's what we're going to be talking about today. It could be various different types of functions. It could be a straight line function, which we're going to work with, but it also could be, they could be on a curve. Okay, so whenever we're talking average rate of change, From the average part, we're going to be dividing, and the rate of change, it's a rate, so we're going to have the units of y in the top and the units of x in the bottom. So we're doing the change of y over the change of x. We always need 2 points. Okay, we may have more than 2 points, but to find an average rate of change, we're looking for the change between 2 points. And what we're trying to find out is, let's see how if we do the average rate, we get, we'll pretend that's a straight line connecting them. Oops, not that one. What we're looking for is what was the change, what was the horizontal change over the vertical change. So in this case, the change in y over the change in x, right? Mathematically, how do we calculate change? Division will give us a rate. Subtraction. So if I get a raise in my salary, my old salary minus my new salary gives me the change, the amount of change. Good. So one way we can work this one out, and we'll look at some examples. So this is trying to get a deep understanding, is, well, first of all, one way we could do this, let's just kind of do this the visual way, is if we plot the points, we draw this triangle, we could just count from this point to this point, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way to get the change. So the change of x was 9, and in the positive direction. The change in the y is 1, 2. So would it be appropriate to say that our average rate of change of y over the change of x, is going to be 2 over 9? And that's exactly what average rate of change is. We're also going to call it the slope. So we use multiple words with this. It's really only the slope when it's on a straight line. Okay. We will also use it as average rate of change, which applies to all curves, whether they're straight lines or not. And you'll see this used as you progress, and if you go into calculus, it's really the focus of calculus is average rate of change. So what's another way we could have found this? Well, what if we hadn't drawn this picture? Could we do it from just knowing the points? We could have taken our points, 11, 4, and 2, 2. And I'm going to do it kind of in a different way, and then we'll look at the formula that maybe you're familiar with. But we could take one point and subtract it from the other. Now, which point is, which of the ordered pair is first, the x or the y? Input, good. And the output is the second one. Okay, so what we do is we can take 2 minus 11, just subtracting one point from the other, lining them up this way, and what do we get? 9, positive 9. And then we take 4 minus 2, we get 2. And then what we can do is we can take the x-coordinate, move it under the y-coordinate, and here's another visual way sort of getting the rate of change. And you don't have to worry too much about getting things lined up because it's already an ordered pair. We'll just line them up one above the other, subtract straight down, and then tuck the x under the y. This was what, unfortunately, I didn't figure this one out until I was a teacher. It would have been nice when I was a student because these are the types of problems that actually gave me a lot of problem. Type of questions that gave me problems.
Is this how we find the slope?
It's how we find the slope. Yes, so what I've given you so far is 2 ways to find the slope. We could plot the points and count, which works fine if it's a small amount. We've got some graph paper lying around. But as the points, maybe the numbers on the points become large, this might be cumbersome. this way will always work. And I'm going to show you one more way, which you probably have seen in the book and the formula, and you've probably been taught before, and that there's this formula that the slope, or the average rate of change, can also be found by taking y sub 2 minus y sub 1. So one of the y coordinates minus the other y coordinate, divided by what? X little 2 minus x little 1. But it seems like, you know, we all get hung up on these little subscripts. And is it the 1 that comes first or the 2 that comes first? And we find out that's not really important, because I get to choose which one's second point, which one's first point. So actually I can work them either way. But if you're familiar with this formula and it feels comfortable to you, you're welcome to use it. And I'll show you that we'll also get the same answer. The problem I have is getting the right y in the right place and the right x's. And sometimes I put the x's on top, and sometimes I put the y's on top. And I'm never really 100% sure that I did it right. But when I line it up like over here, I'm going to put this as the Vedic way, from Vedic math. This process helped. This way over here is the visual way. And this one is the formula way. Okay, so then I take our 2 points. So let's see, y2, let's go with this, the second point being 11, 4. So y2 is 4. y1 is 2. x2 is 11. And x1 is 2. So we can do it this way as well. And we end up 4 minus 2 is 2. 11 minus 2 is 9. 2 ninths. Again, we found our slope. We found our average rate of change. This is what we're going to be doing again and again and again. Okay. And when you get to calculus, you're going to see yourself doing this as well. It might not conceptually at first look that way, but you'll be seeing that that's actually what you're doing. Is you're subtracting the y values in the top, you're subtracting the x values in the bottom. And I just got 3 different methods, and you just kind of figure out which one works more naturally for you and with the way that you think and the way that you've learned it. Okay, so formula way, Vedic, visual, and I'll just label them A, B, C, because it doesn't, you know, it's really not first, second, third, although A, B, C seems like it is. But just 3 methods, any order, whichever you prefer. Okay, so let's take a picture of that screen. Let's put it here. And let me check, because the other problem I had, this class we were fine, which is good. My other class, the video I had down working just fine, but their pictures, it wasn't capturing the whole screen. Let's see what's going on here. Maybe I can't. Okay, and we'll keep going. Hopefully it's taking the whole screen. I'll check at the end, because we're going to add another page, and so if we need to go back, just to let you know, we can always come back and discuss it. Okay, so that's there. I'm going to take the grid away, unless we need it later. We can always get it back. And we'll pull up our there's that. it's there. Let's just check it real quick while we're here. Yeah, we got the full screen. Good. Okay, let's test it out now. Let's see if I can get this. Upgraded to the paid version and it, okay, there, now it seems to be working. Okay. So average rate of change. And these are the types of things you'll see on a test question. And when we get to the end, we'll be doing something called regression with these. So you really have to be careful what is the question asking. Sometimes it wants us to find the equation of a line that would fit this data the best. That's what we'll be doing in 3.5 and 3.6. But in this case, what they want from us is that they want us, let's see, what are we, if we are interested in how gas prices changed between 2002 and 2009. So they're kind of working it out for us. What they're looking for is the average change. And so if it started in year 2000, then year 2 is 2002. Would you agree with that? Okay. And the 9 year must be 2009. And notice, to find out the difference, what they did, which maybe they didn't really show what they did, they're taking this y value and this y value, subtracting them, and then taking the two x values and subtracting them. They're really ignoring everything in between. So let's go ahead and do that with one of our methods. So I'm just going to write it over here, 9, 2.14. and 2, 1.47. So 9 minus 2, subtract, right? 7. That's where they got 7 years. They did the subtraction up here. And then 2.14 minus 1.47. Let's see if I can get that in my head. That's 3, so that should be 7, 6, 67, 2.14.
0.096 is the answer, because when you move it over and then you add the 1, so it was 0.096.
I got
0.67. Okay, it's 2.14 minus 1.47.
And that was 0.67.
0.67. Yeah, which is what they got here. And then notice what my method is just to take that 7, tuck it underneath, divide by it. So take 0.67 divided by 7. Do you get the, so, oh, you went a step ahead of us. Okay. Okay, 0.096. Good. And that's all there is to it. Okay. So, and notice though, since we're dealing with points, every point has two components, an x and a y component, an input and an output. So we're dealing with 4 numbers here, and if we're not careful, it's very easy to confuse them, to subtract the wrong things, to put the wrong thing in the top or the wrong thing in the bottom, maybe to do a rounding error or something. But if we just write them as ordered pairs, subtract them, tuck one underneath the other, and then we're going to be able to get the answer straight off. But in this section, finding the average rate of change deals with just 2 points. Okay, just 2 points. Okay. And again, they give the example here. Notice instead of using y's, I'll just highlight this. What is this value they're talking about, f of x2?
The function of?
The function of, which is really, when we're talking just in terms of x and y, isn't that really just y2? The function at x2 means the output, which means the y value. And the same thing, f of x1 is another way to write y1. Okay, so this might be a little unfamiliar way of seeing the slope formula, but it really is the same. And what they're doing is this is how the slope formula appears when you start doing calculus. So it's kind of like getting you ready. I know you got another college algebra, and then before you get into calculus, but this is what you'll be seeing in calculus. So we're wanting you to not be, when you get to calculus, think it's all something completely new. It's really the same thing you've been doing all along. Okay, so and again, this is the same thing we were doing, because when I'm doing it vertically, what am I doing? I'm taking x2, y2, and x1, y1, right? But I do it with numbers. I'm subtracting them, and I get a value. Subtracting these, I get a value, and I take my value and tuck it underneath. So it's really the same thing that we're doing when we just take the points, but it's a little bit easier because then we don't have to use formulas. Okay. How's this going so far?
So far, so good.
So far, so good. Doesn't feel like anything new yet. Good. In fact, actually, there shouldn't be anything new at all today. But okay, so that's the basis of everything we do. And again, some examples. Another example. Let's choose one of these. Which one? A, B, or C?
C.
C. Okay. So we'll go with C. It's asking us to find from 2005 to 2007, and what we're looking for, average rate of change. So since the input is starting the year 2000, where's 2005? 5. Very good. And 2007 must be the 7. Okay. So we can just take these points, these 2 points, line them up. I always like to take the bigger X on top, but it'll actually work either way. And then we'll write the other point, 5, 2.30. We subtract 7 minus 5, 2.3 minus 2.3. Take the 2, tuck it underneath. 0 divided by 2 is still 0. So notice, so what's the rate of change?
There's no change.
There is no change, which is 0. Okay, but be careful, there's also, we'll see later, if the 0 would have been in the X, that's a, That gives us a vertical line that's actually undefined, because division by 0 is undefined. But this is not the one that's undefined. This is a slope of 0, a rate of 0, which means constant or no change. And again, on a graph, here's 5, here's 7. What it would look like is we've got a point here and a point here, so it looks like it's going straight. Now in between there was some change, so it did go up and come down, but the average change between these 2 years is 0. Okay, so that's average rate of change does not take into effect the actual data that happened in between. It's just where did I start, where did I end? Make sense? Okay, awesome. That's a good one. So now let's get, so we got average rate of change. Wants to practice on some word problems. Should we do one word problem? Okay, we'll do the you try, because I think they've got the answers, but they don't work them out. So why don't we work them out? There'll be a little bit of video on this. Okay. So we got the blue. Okay. So first of all, before I start reading, what I start to do is I look for numbers. You see a number? Underline it. And let's see, let's find some other numbers. So here's 8 months. And sometimes I'll underline the units that go with it too. That's all the numbers we have, right? Anyone see any other number? No. I don't. Okay, so now that's the other thing I do is I come to the end to try to see what the question is. And usually I find that's in the last sentence. So I don't start reading the first sentence. And I look for a question word or action word like this is determine. So this is telling me what to do. Determine the average rate of change. Okay, average rate of change. So that now we know what we're looking for. But we know for average rate of change we need how many points? 2. And that 2 points has how many numbers associated with it? 4. And we only found 3 so far, so now we're going to have to find out where the missing number is. A lot of times it's 0 because that's what we started with and they don't mention it. So let's see if that's what the case. You opened a savings account and deposited $50. So when we opened it, what was the time? 0. So we start, the day we opened it, that's the beginning of the account. So our first point really is 0.50. Each month you deposit money into that account after paying bills and other expenses. At the end of 8 months, you had saved 526. So what's our other point? 8 months, 8, 526. And this is sort of the key to doing word problems, at least in this section and in math, is when we're talking linear equations, there will always be either 2 points given to you, you find the 2 points, or sometimes they'll give you a rate of change. They'll give you the slope and a point. So they have to do that. But the rate of change, so if you've only got 3 numbers, it could be that they gave you the rate of change and a point. But they didn't do it in this case. So how do we do this one? 8, 526, 0, 50. And again, we just take the points and subtract them. Subtract the x's from the x's and the y's from the y. Put the y on top and the x on the bottom. 8 minus 0 is 8. 526 minus 50 is 476. Good, I think. Right?
Yeah.
Good. Yeah, I always go with my gut feeling and then I have to check it to make sure that that's right. Usually it is, but usually I double check myself, right? So 476 divided by 8, and so now since we're actually looking for the average, maybe a dollar amount, we could go ahead and divide that. Another nice thing about having this is I should just bring the calculator over here. So 476, because this is another area where I'll find some students will do it because of the way we teach you to do division. You do it in the wrong order. You do, put in the calculator backwards, but what we should have is 59.5. Is that correct?
Mm-hmm.
So on average, we saved $59.50 a month. Now, some months might have been more, some less, but on average, that's what we did over the 8 months. Seem reasonable? Okay. And so again, that's the way is when you look at word problems, look for numbers first, because what we're looking for is 2 points, an X and a Y, an X and a Y. Look at the units, and the units will match up what is the X and what is the Y. Usually when time's involved, your time is going to be your X, like 99% of the time. It'd be real. Occasionally it's not. Very rarely I'll say it's not. So you're safest just to assume that if we got time involved, time is your X. Your X is time. Okay. And then the other units are your Y values, your outputs. And once I can't remember what it was, but this was when I was a student. I finally recognized this after years of working on things and thinking word problems were so hard. When I figured this out, I could just look for numbers, and they were either giving me 2 points or they were giving you the slope at a point. And it makes doing word problems much easier. Okay. That's good. Okay, let's make this a little bit longer. This is a media example, so I'll let you take, I'm just going to discuss it, but if you want to see it in great detail, you can watch the video on it. Okay, so what they're asking us here is like, for the A question, is it from X equals 0 to X equal 1. So from this point to this point, to find the average rate of change on each of these. Okay, from this point to this point, and from this point to this point. And so they'll find the average rate of change for both of those. And you'll see that if we go from the beginning to the end, both, it looks like all of them actually have the same rate of change from beginning to end. Mm-hmm. Right, because they're all starting at the same point, ending at the same point. But this one will have, the interim rates will be different. This one sort of is a different rate, and this one's a constant rate. Okay, so they have you find those. I think I'd encourage you to take a look at the video. It's a lot of detail, but average rate of change is just taking the change between 2 of the points. And again, what it's doing is it's assuming sort of like it's a straight line change. So when you get the average rate of change, you're getting this, not the curve. This. And you notice they're all increasing, but one of them, this one, what do you think is actually happening to the rate as it gets closer to the top? It's decreasing. It's actually slowing down. How about this middle one, B? It's increasing. So it started off sort of slower and was picking up momentum. And C is a type that is just constant rate. Okay, so 3 different, and those are the 3 cases you deal with in calculus. Again, this problem is intended to give you a good foundation for when you start working with calculus, or before you start working with calculus. Okay, so again, there's a video that has this one very much in detail. So I'll let you go ahead and take a look at that one. And now what we're going to do is spend about the next 20, 30 minutes, and we're going to talk about linear equations. Okay, so a linear equation has the form f of x, or y if you want, equals mx plus b. What does the m stand for? It's the slope. Okay, it's what we were just finding, the average rate of change. We call it the slope when it's on a line, so that's exactly what we're doing. What is the value of b, what does that give us? A y-intercept, the starting value. Because if you plug in 0 for x, 0 times whatever the slope is going to be 0. The y value is going to be this when x is 0. So this is our y-intercept, also called the vertical intercept. And again, it gives us the point, the vertical intercept is that when x is 0, it's the y value. Okay, so what we'll do is we'll just do a little bit of review. We're looking at some linear equations. We're just going to, from the equations themselves, be able to identify slope, vertical intercept, and the behavior just by looking at it. Okay, so let's come up to A. So, well, actually they give it to us all, right? Where's our equation? It's here. So where do we find the slope? In front of the x, it's the -2. How do we know it's decreasing? Because it's negative. So we're going down. Because remember, another way to think of slope, we talk about it as rise over run. So a negative slope must have a negative rise, which means it's falling over a positive run. Okay, so this is a decrease. Good. And then the vertical intercept, we got it directly from here, starting value. It's the y value when the x value is 0. Okay, and so the rest of these are set up, and again, they've been answered for us. This is one that will throw some people. When we have x equals a number, what do we have? A vertical line. When we have y equals a number, or f of x equals a number, what do we have? Which kind of line is this? What's another? We call it a straight line oftentimes, but what's another word that starts with an H?
Horizontal.
It's the horizontal line. So it's and it's constant. It's, you know, so there is no increase or decrease. So another way to think of this is a horizontal line. And I know, again, a lot of people, vertical lines are straight, but I know I do the same thing. I call it a straight line, and I mean horizontal because I don't like using the words horizontal and vertical because I mix them up. Okay, so it's that way. This one is this way. Okay, and we see all the different ones in between. Okay, so now we're going to take a look at some unworked examples. More worked examples. Here we go. So for this one, let's just go through this, see if we can identify the slope, the vertical intercept, and the horizontal intercept. We'll add one more thing into it, into the mix. So how do we find the slope? The number in front of the x. Not always the first one, because sometimes they do b plus mx. So it's the number in front of the x. And in this case, it's a fraction 3/5. Rise of 3, run of 5. Okay, we'll use that a little bit later. How about our vertical intercept?
-8.
Good, -8. Now if we write it, the word vertical intercept is, what is it indicating? It's indicating where we have a point. And when we write a point, how do we write a point? X as a pair. So we don't just write -8. Sometimes we know what we're talking about, but if they're asking for the vertical intercept, the most correct way to do it is 0, -8. Okay. So -8 is a correct answer, but it's not a correct form necessarily. And in Math AS will get on you about this if they ask for a vertical intercept, they're looking for an ordered pair, and that's it. But this helps us if the vertical intercept is 0, y, what's the horizontal intercept going to be? Comma 0, I'll give you that much. This is a harder one because we can't just find it by looking at the equation. This one we actually have to do some algebra. Notice we're putting 0 in for y, the output.
Wouldn't it be positive 8 because don't you do, like, you have to add the 8 to both sides?
Very good, but there's more to it than that too. Good. So right, we're going to now have to solve. So this is where, when they ask for the horizontal intercept, it's like, I don't know, it's too much work, right? I can't just tell by looking. That's why I like to skip those ones, at least at first. So yes, we add 8 to both sides. And we get 8 equals 3/5 x. Now what do we need to do?
Multiply each side by 5/3.
By the reciprocal, very good. So we multiply both sides by 5/3 so that this cancels and this cancels. 5/3. So we end up with x, 5 times 8,
40.
divided by 3. And we could just leave it like that. We don't like mixed numbers in algebra, at least I don't. Sometimes I know Math AS will ask you to write it as a mixed number, but I apologize for that. It shouldn't. Algebra, we don't use mixed numbers anymore. We use either improper fractions, with perfectly proper, or we use them as decimals. Okay, so you could take 40 divided by 3 and you'll get a decimal. 13.333 maybe, something like that. Okay, but that's the horizontal intercept. Again, that's the most annoying one to find because you gotta actually do some work. Okay, so far so good. Okay, so let's save that one. And here we're going to actually plot them. We're given a function, which is good. And again, let's see, I think this is a media lesson that media example. So there's a video that's already worked this one out. I encourage you to at least take a look at it if you do it your own. But basically, notice they took the years, they renumbered them. 1999 became year 0. So year 1 is 2000. They did this. And then you're going to use this formula up here, plug in the t-value, find the output, and then somehow plot it on a graph. Okay. So again, they'll walk you through that. What I want to do, and here's another one, it's a U-try, it's similar. We'll come back to these. Okay, so this one's going to help us because we're going to take a look at the graph and be able to answer some questions about that graph. Let's see. Make it a little bit smaller so we can get, can you still read that okay? Get a few more questions on the screen. Okay. So we've got this graph. So identify the vertical intercept. So where's the vertical intercept? Here's x equals 0. How about right here? 15. And again, we could list it as a point 0, comma 15. And write it as an ordered pair. So that's label it on the graph. We did that. Interpret its meaning. Since this graph is about Sally's distance from home over a 30-minute period, where is Sally with respect to her home?
15 miles.
So way, yeah. Distance from home, we don't know if she's east, west, south, but we know she's 15 miles from home. Okay, good. Identify the horizontal intercept. And again, this one is, the horizontal is laying down. So here's this one, and what would we call this point? Home, because 30 comma 0, the y is 0, so we're at home. Good. What does the 30 represent? Minutes. So it took her 30 minutes to get home. She is. She went 15 miles in 30 minutes. We'll calculate her rate of speed. And we'll see, she probably was not walking. Okay. Right, is it order paired, right label on the graph? Now determine the slope. So how can we get the slope from what we've got so far? Yes, so what do we do with our 2 points? Subtract them. So we could take 30 comma 0 minus 0 comma 15. And this is why using the vertical intercept and the horizontal intercepts are really nice, because the subtractions are real easy because it always involves a 0. 30 minus 0 is 30. 0 minus 15, negative 15. I take 30, tuck it underneath the 15, and I get that her rate of speed is negative 15 over 30, which reduces down to 1 over 2. 1 mile every 2 minutes. Remember, the units on here, the bottom is minutes, the top is miles. So if we were to convert this to miles per hour, how fast was she going? 30 miles an hour. Because 1 mile because a mile a minute is 60 miles an hour. If she was taking 2 minutes to go a mile, so right, you could also do the blown out math, but it's, yeah, your gut feeling, this is 30 miles an hour. So she wasn't, she's in a residential neighborhood, she's going maybe 5 miles over the speed limit. If she's on the freeway, she was going a little slow. And if she was running, she's fast. Yes, get her into the Olympics, right?
Maybe she was biking.
Maybe she was biking, yeah, and even for biking, that's fast. I've got an electric bike, and even with the electric motor, it only gets me to 20 miles per hour. And I don't think I can keep up with that. So, maybe some of you could. Anyway, and why is it negative?
Because the y was oh, it's a downward slope.
It's a downward slope. She's coming home. Had she been going away from home, it would have been positive with that reference point. So she's getting closer to home, so a negative slope. So in units, it's negative 1, 2. A drop of 1 for every 2x units. So every 2 minutes, she's got 1 more down. Determine the slope and interpret its meaning in a complete sentence. Basically, we said it, 1 mile closer to home. Every 2 minutes. And then we converted it to something that's meaningful to us. She was going 30 miles per hour. But you see how we can, take these same concepts, finding average rate of change, and apply them in various settings. Visually, with the formula, with the Vedic math system, where we're just subtracting straight down and then moving the x over, dividing by the x. Okay, we've got, let's see, got a few more questions, but we'll skip those. Oh wait, maybe we should. How did we do on domain and range? Would it be good to do a little bit of review? Yeah. Okay. Domain. What is the domain? The horizontal. So we want to go from here to here. So what's the domain? Good. So the beginning, I would use brackets because we actually are there, right? We did start it, have a starting point, and after 30 minutes she was back home. Hopefully went inside and we're done. Okay, so I would put brackets rather than parentheses. She just got there. How about our range? That's the vertical.
15?
Good. And even though in the story it was 15 to 0, right? She started 15 miles away, ended up being 0. We always list the range smallest to largest. So we list as 0 to 15. And again, I would use brackets because she was actually at these places. She was actually 15 miles away. She was actually at home.
When it asks for the inequal notation, is that when it's less than?
Oh, yes. So this is interval notation.
Yeah.
Inequality notation. Here we write it as 0 less than or equal to, did we use f of x? Or, I don't know, y. Whatever we used for the function, less than or equal to 15. For the domain, we do the same thing, 0 less than or equal to x less than or equal to 30. And watch this, I've had a few students contact me like in MAT121 and one of the problems, she thought she had the range correct, which she did, but she had x in the middle, not f of x. It's real picky. So the range, you have to have the y value, the output value there. But those are the two types of notation. This one is interval. And the one over here is inequality. Okay, so that takes care of that problem. And I want to finish us up here if we, yeah. So we'll look at, they got media examples, but we got some worked examples. They've got some U-tries. Let's do the U-tries because you've got the media examples. You can look at those videos. Okay. So there's really just 3 steps or 3 things we can do here. Give you 2 points, find the equation of the line. Give you the slope and a point, find the equation of the line. And then we're also going to talk about parallel and perpendicular lines, what happens with those. Okay, so we have 2 points, as we do here in A. How do we go about finding the equation of the line? Okay, good. Make it a little bit bigger. So we'll, for this first one, we'll first find the slope. And then once we get the slope, we'll plug one of the points in to find the y-intercept. So we can 3, -2, and 1, 4. Okay, again, subtract the x's. 3 minus 1 is 2. -2 minus 4, -6. And then we divide, put the 2 in the bottom. 6 divided by 2, -3. That's our slope. Okay, so what we know is we've got y equals -3x plus b. Okay, we don't know the y-intercept yet, right? Because one of these points, neither one of them has an x value of 0. So how do we find b now?
We can add 3x to both sides.
Well, because we've got a y, we have too many variables. So we got to get rid of, we can only solve something if there's only one variable. This is what, again, another point that came across to me late in my career. But you can only solve something if you only have one variable left. And we've got 3 variables. We got, or 3 unknowns at least. We've got y, x, and b. But if we take one of these points, what does one of these points give us? It gives us x and y. When x is 1, we know y is going to be 4. That's what an ordered pair is telling us. So we're able to plug them in. The 4 goes in for y, the 1 goes in for x, and now look, we've only got one unknown. So yes, with negative 3 times 1 is negative 3, and then we just add 3 to both sides to get the b by itself. So b is 7. And so our equation, and that's what we were looking for, is y, or if you want f of x, whatever they're asking for, but this is the basic one, y equals negative 3x plus 7. Just like that. So let's find the slope, take one of the points, plug it in to find the y-intercept. And you're going to see that's really the process in all of these. Okay, so far so good? Questions? Not at this time. Good. Okay. 2 lines are parallel. What do we know about them?
They have the same slope.
Do they have to? If they didn't have the same slope, what would happen? They would cross someplace. So yes, they have to have the same slope. I liken this to, I don't know how old I was, but my younger brother, 7 years younger than me, and we were like best of friends. I was the oldest boy, he was the youngest boy. And I remember him saying to me, he goes, I can't wait till we're the same age. Because he thought from his perspective that he would get older and I would stay the same. And I had to break it to him. I says, sorry, brother, but I'm going to be getting older here. As you get older, I'm going to get older. That's a parallel line until, I said, the only way you're going to catch up to me is for me to die first. And then I guess you can catch up to me, but right? But that's a parallel line. We've got the same rate of change. We're both getting older. Okay? A little bit morbid, but he got the point. So parallel lines are going to have the same slope. So what these questions are doing, they give you one line. So find the equation of the line parallel to this one. And the important thing is if they're parallel, we know that the slopes are the same. What's the relationship between the y-intercepts of 2 lines that are parallel? And don't think too hard, there is no relationship. Because I can have 2 lines that are parallel this way, or I could have another parallel line here, and the parallel tells me nothing about their y-intercepts. It just tells me about their slopes. So one of the key thing is when you're given this equation, ignore the y-intercept. And that's one of the problems I'll see. People will try to use that y-intercept in the other equation. But it has nothing to do with the other line we're talking about. So what we know, what they're really telling us, is that we've got a line that has a slope of 2/3, and it goes through this point. That's the way to think of these parallel line questions. So what we have is we have y equals 2/3 x plus b, and we want to plug in the point 3, 4. We don't want to use the other y-intercept because it has nothing to do with the problem. And if you learn to ignore that part, you'll just things will just fall into place. Usually that's the biggest problem is people feel like you have to do something because they gave it to you, right? And they said, well, if they give me information, don't I have to use it all? No. That's the cool part of math. You can ignore a lot of stuff. In fact, you have to learn to ignore a lot of stuff. Okay, so we do like we did before. Again, plug the x in for x, the y in for y. So this one we've got 4. Y is 4. My y. We've got 2/3. We're going to plug in 3. And what can we do with the 2/3 and the 3?
Multiply.
We can multiply. So you multiply straight across, and do the 3 and the 3 cancel? Yes, indeed. If you wanted to, you could write it as 6/3, but that will reduce down to 2. Okay. So what we have is 4 is equal to 2 plus b. And then what do we do? Subtract. Good. Subtract the 2. Awesome. So then b equals 2. And then we write our equation, y equals 2/3 x plus 2. That's all there was to that one. So again, we had to find the slope first, but this one we found the slope by realizing what the relationship parallel means, same slopes. Okay. Took the point, plugged it in, and found the y-intercept. One more. What does perpendicular mean? Try this. Okay, now look at your hands. What's the slope relationship of your arms? One's going up, one's going down, right? So one's positive slope, one's negative slope. Perpendicular also means a right angle, a 90-degree angle. But when you do this physically, you're telling yourself, okay, one line's positive, one line's negative. That's one thing you want to remember. The other thing that is just kind of a cool feature, that when we have perpendicular, when we have exactly 90 degrees, what happens, the rise and run also change places. So we get a reciprocal. So again, you might want to go through this in a little bit more detail, but perpendicular means if I have a slope of one line that's 2/3, what's going to be my slope of a line that's perpendicular? 3/2. Since this one was a positive slope, what's this one's going to be? Negative. So there's just two components to it. The signs will be different, and the fraction will be flipped, a reciprocal. Okay, so again, it's a little bit more complicated, but this is what we start with. We start with a slope of -3/2 because we're looking for a line that's perpendicular to this one. Again, did we use the y-intercept off of this line? No, we didn't. In fact, I said just cross it off because now we're not tempted to use it. Okay, just cross it out. We're not going to use it. That's took me years to figure that one out. I always wanted to use it somehow, and that always messed me up. So again, now we've got just a simple problem. Y equals -3/2x plus b. And now we take the same point, or what the point they gave us is 4/3. We plug the x in for x, the y in for y. Let's change colors here. Let's go with green. So the 4 is going to go in for x, the 3 goes in for the y. So we get 3 equals -3/2 times 4, and I'll write it as a fraction 2, 4/1 plus b. 2 and 4 can, or 2 goes into 4, right? They don't quite cancel. We're left with a 2. 2 goes into 4 2 times. So what are we left with here? -3 times 2 gives us a -6 plus b. And then to finish off, add 6 to both sides. So b equals 9. We have our slope, we have our y-intercept. We can just write the equation y equals -3/2 x plus 9. The cool part is if you graph this line and you graph the original line, you'll see they're perpendicular. One's going up, one's coming down. They do cross at 90-degree angles as well. Okay. We do that okay? Okay, and I think that's about a good place to stop. We still have about 30 minutes for some questions or homework if you'd like to. What we'll do on Wednesday is I'll show you how to use the calculator. So TI 84 or 83 work. Okay, so you'll want to have one with you if at all possible, because it's best as we work through these for you to actually be putting it in and being in the driver's seat. But I'll show you how these calculators actually can come up with all of these equations we just did by hand. It'll do this, but it'll even do more. If we have 10 points and we want to average them out, it will also get us the line of best fit in addition to that, which I used to have to do those calculations by hand back when I was going to school back in the early 80s. So technology has been a nice thing for us. So we'll get to those. Any questions before we, yes?
Question. On C, what is, well, it looks like a 1 with an underline under it. What is that meaning for the equation? Over on the left-hand side. Yeah, right there.
This? Oh, thank you. That's the symbol for perpendicular.
Oh, okay.
So it's thank you. I didn't describe what that means. This is I don't know if it's a mathematical or it's just my teachers used it, so I use it, but it's my way of saying perpendicular.
Okay, thank you.
And it shows you if you need to use a symbol and you want to make one up, you can, as long as you let everyone else know. So that's, yeah, perpendicular. Just remember, slopes will be the reciprocal of each other, and one will be positive, one will be negative for perpendicular. Awesome. Thank you very much. Hang around for any questions you may have, and we'll see you all on Wednesday. Word of the day. Who's got a good?
Basketball.
Basketball. So I can, oops, not there. We'll go with that. Orange would be a good color because basketballs are orange, right?
Yeah.
Basketball. So that's our word of the day. Okay, those in the live stream, I live streaming it again, so there's basketball. You'll be able to validate attendance with that.